Hello students, I welcome you for the online classes of computer science of first PUC. Students, as you know, we are there in unit A, that is fundamentals of computers. In this chapter 3, data representation, we are studying. Students, we have already learned the introduction about number system and why we have to study number system. And in the number system, the two types of number system already we have seen: non-positional number system, positional number system. In position, we have learned the four types of number system, that is decimal, binary, octal and hexadecimal. And at the same time, we learned and we are learning the conversion from one number system to another number system. In the last session, we discussed how to convert the decimal number to binary. In the decimal, we calculated the binary equivalent in two ways. That is, we taken up the integer part and the fraction part separately. For integer, we used to divide successively by 2. For fraction, we used to multiply by 2. Similar way, we learnt binary to decimal conversion. In this session, I am going to discuss with you paper, that is decimal to octal conversion and octal to decimal conversion. The other part maybe I am going to discuss in the future sessions. So let me keep it in front of you. Decimal to octal conversion. So before going to that, let me keep it in front of you, the procedure. Now first procedure, when I am going to keep it in front of you, just wanted to tell you people how exactly you did with the binary. Similar way only here is doing. That is, when you wanted to convert decimal to octal, first you have to take up integer part. And how exactly we are converting? We have to divide the given decimal number by 2. In the second step, we have to take the remainder and record it on the right side. And the step 1, step 2, we have to keeping on repeat till we cannot divide it further. And at each iteration, we have to record the remainder. And the step 4, the first remainder we have to treat it as a LSB, and the last remainder we have to treat it as a MSB. So which is LSB and MSB I told with you. The most significant bit and the least significant bit. The octal number is then written from left to right, that is from MSB to LSB. So this is a procedure. Same way what you have seen in the binary. Let me keep it in front of you one simple example. So let me take this two decimal numbers. I have taken up 459 and one more is 334. Now how to convert to octal? Yeah? Yes, students. So I'll keep it, the first number I'll take 459. I've taken up 459. As I told with you, I'll divide it by, I've noted down here, and where I'm quotient, I'm recording, and then the reminder I'm recording. So first, what I'll do, 459, I'll divide it by 8. I'll get 57 quotient. Okay, and 3 as a reminder I'll get. So I've recorded in the right side. Yeah. So this is, you can do it by using calculator. Again, I'll divide 57 by 8. I'll get 7 as a quotient, 1 as a reminder. Again, I'll divide. I'll get 0 as a quotient and 7 as a reminder. Further, I cannot divide. So what I'll do, the first reminder I made it as a LSB, and the last reminder I made it as a MSB. Now what is the equivalent? That is octal equivalent for the given decimal number. We have to read from the down to upwards, and that means 459 is equal to 713 in octal. This is the way we are doing. Let me give you one more example, that is 3034. So again I am taking 3034, and what I'll do, I'll divide it by 8. Correct now? I'll get 379 quotient and 2 reminder. Again this 379 I'll divide it by 8. 47 I'll get quotient, 3 reminder. Again I'll divide, 5 I'll get as a quotient, 7 as a reminder. That you know very well. 8 into 5 is a 40. So 47 minus 47 remains, that becomes reminder. So this is, if you know, keeping on, if you do with everything, you get this is the way, quotient as well as a reminder. Again this 5 we cannot, that becomes a reminder, 0 becomes quotient, further we cannot divide. So last reminder MSB, first reminder LSB. We have to read from down to upwards. That means what is equivalent? 5732. So this is what, dear students, 3034 in decimal, 5732 in octal. This is the way the integer part of decimal number we are converting to the octal. Got it right? So then we have to learn how fraction numbers will be converted to decimal, because that is also very important. Yeah. So keeping in front of you, that is the fractional part converting to the octal. We already seen in binary, no? Same procedure. Only the thing, there we used to use 8. There we used to use 2. Here we are using 8. Why we are using 8? Because base of this number system is 8. So first step says that multiply the given decimal fraction number by 8. Yeah. And note the carry and the product. Repeat step 1, step 2 until fractional product becomes 0. The first carry will become MSB and the last carry is the LSB. The equivalent of fraction number, that is octal fraction number, is written from MSB to LSB. So same procedure. The procedure is not changed. What it is changed here? Only the multiplication by which number. So that is base of that number. So let me give you the example. It gives more clear. Yeah. So before than that, I just wanted to keep it in front of you. That is a note. See, the fractional product does not become 0. You are keeping on multiplying by 8. Some cases it will not become 0. Then we can stop with the 5 to 6 iteration. No need of doing more. So we can stop that 5 times. If you do, that's more than enough. Okay. So binary it is happens 0 comes, but normally octal it may not. So that is the reason we just kept it in front of this note. Yeah. So let me take an example. I'm taking the example. The decimal number is 0.3125. This is a decimal. Now I wanted to convert into the octal fraction part, right? So what the procedure told us, we have to take this fraction and multiply by 8. So what I did, I have taken up and multiplied by 8. So I got 2.50. So this 2 what becomes carry. So I recorded in the right side. And this is the fraction part I have sent here. That is 0.5. 0.5 I multiplied by 8. I got 4.0. Make use of calculator, my dear students. So while watching this video, you pause it and calculate in the calculator, so that you're working along with this video. Because what happens, I have already put in the slides. So if you just look at blankly, then it may not remains. So you can pause this video and you can do practically by making use of calculator. So that time you will come to know. That's the reason I'm telling. Okay. So 4.0 comes. So again here what happens? I am taking the carry 4 here. Now 0 it goes. No further multiplication because it becomes 0. Now as we understood from the procedure, first carry becomes MSB, second means last carry becomes LSB. And we have to note on MSB to LSB, that is up to downwards. Correct, right? So that means 0.3125 in decimal. What is the octal equivalent? 0.24. So this is the answer, my dear students. Got it, right? Okay. So this is what, how exactly binary is the same way. So only the thing we have to become a smart, we are making use of the base of that number system. So let me keep it in front of you one more example, which is both together, the integer and fractional part together, conversion to the octal. So that let me keep it in front of you, this example. So I have taken up the number 2020.671875. I wanted to convert into the octal. Now what I have to do, I have to take first integer part, I'll take it here, then I'll take it fractional part. So 220 I'll take it first and I'll convert into the octal. So that is, this is the way. I'm multiplying, dividing by 8, the 220, I'll get to 252 as a quotient, 4 I have taken up a remainder. Got it? So again I'll divide by 8, I'll get 31 and then 4 remainder. Again I'll divide 3 quotient, 7 remainder. Again if I go 0 quotient, 3 remainder. No further division. So last remainder MSB, first remainder LSB. So we have to read from down to upwards. That means 220 in decimal, 3744 in octal. So I have noted down here. Correct, no? Now next part, what you have to do? You have to take fractional part. So that we took here. Fraction part, what we are doing? We are multiplying by 8. So I multiplied 0.671875 by 8. I got answer 5.375. And this 5 becomes carry. I have to put here. Again 0.375 multiplying by 8. I get answer is 3.0. So 3 becomes carry. And 0 goes here, no further multiplication. So I stops here. First carry is LSB and second carry becomes LSB. As we know, we have to read from up to downwards. So therefore, 0.671875, it's in decimal, and 0.53 is octal equivalent of that. So this is the way. Correct, no? Now final, I wanted to write for 2020.671875 together. So that is writing in. This is the way, my dear students. So this is a given number. So integer part we have to write first, and then fractional part we have to write. So this becomes a together answer. This is the way we do. Yes. So this is about decimal to octal conversion. Now I want to do ulta. Octal to decimal. How to do? So that is also where it is required, right? That is also we have to study, right? So let me keep it in front of you. First, let me keep it in front of you, the procedure. Yes. What you have to do? So here we are following the steps that converting octal integer with the fractional part to decimal. Together we do. Not like a decimal to octal. There we have to consider integer part separately, fraction part separately. But when you wanted to do conversion from octal to decimal, together we can do. How? See here. Step 1, start at the rightmost bit and then multiply by 8 to the power n. When n is the current position beginning at 0, then increasing by 1 each time. This represents power. Okay? This represents power. So this is what you have to keep it in your mind, my dear students. Nothing else. Okay? So same as you have seen binary number system, same way. Then that all those products are there, no? You add it together. And that sum after addition is equal to the decimal value of that octal number. So this is a procedure, my dear students. So let me keep it in front of you, the example itself. I don't waste my time. I'll keep it. So very simple, I've taken up this example. 2324.171 octal number to decimal. So as in the procedure they said, first bit you take, for rightmost bit. Yeah, we have to decide what is the weightage of that bit. Now, as you know, from decimal point we are calculating the weightage. Now for decimal point right side we are going 0, 1, 2, 3, and from decimal point left side 0, 1, 2, 3 R becomes weightage. To the right minus 1, minus 2, minus 3, minus 4 it goes. But in your case, 3 is that position value is weightage is minus 3. So therefore what it becomes here, 3 into 8 to the power minus 3. And each time you have to increase by 1. So 7 into minus 2. 8 to the power minus 2 it becomes. Then 1 into 8 to the power minus 1. Then 4 into 8 to the power 0. Then 2 into 8 to the power 1. Then 3 into 8 to the power 2. Then 2 into 8 to the power 3 comes. This is the way, my dear students, you are writing. Got it? This is the way we are noting down. Now what you have to do, you have to take a product of this and then we have to add. So what I'll do here, 8 to the power 3 equal to 512. So that I am noting down, 2 into 512. Now 8 to the power 2 equal to, that is 64. So 3 into 64 I wrote. 8 to the power 1 equal to 8 itself. So that means 2 into 8. 8 to the power 0 equal to 1 itself. that we have learned in maths. N to the power 0 equal to 1 itself. Any number you give, if you make power 0, then the answer becomes 1. So that means 4 into 1 it becomes. Now 1 into a to the power minus 1. So a to the power minus 1, what you have to do? As I told with you, a to the power minus 1 equals to 1 by a to the power 1. Now a to the power 1 equal to 8 itself. So 1 by 8 equal to 0.125. Got it. Next is 7 into 8 to the power minus 2. Now that means 8 to the power minus 2 equal to 1 by 8 to the power 2. So that means 1 by 64. And 1 by 64 equal to is this value, 0.0115625. So I multiply by 7, I kept it here. Same way, the next term, 3 into a to the power minus 3 is there. Now 3 I brought it here, a to the power minus 3 is equal to 1 by a to the power 3. And a to the power 3 is 512. So 1 by 512 equal to, you get 0.100 0.0019532125. You get it. Now after taking product all those things, that is 2 into 512, 1024 you get, 3 into 64 you get 192, 2 into 8 16, 4 into 1 is 4, 1 into 0.125 you get 0.125, 7 into 0.015625 you get it, answer is 0.109375. 3 into 0.0019532125 you get 0.00585937. Altogether when you add, you get answer is 1236.240234375. And this is a decimal equivalent of the given octal number. Let me keep it the final answer. Got it? Yeah. So I told you 2324.173. It's a octal number. What is the decimal equivalent? 1236.240234375. Dear students, this is I just explained. Please work out. Make use of any rough sheet and then work and then see. Then only you will understand proper. Okay. So students, this session let me conclude here. So I will come with another conversion in the next class. Till then, take care, stay safe, stay at home, help your parents. And Navaratri time, so be a little bit devotional, pray with God to bless whole world. Thank you very much.